Well, triple integrals can happen in cylindrical as well as spherical coordinates. And if we're in cylindrical coordinates, what we have to remember is that the xy plane could be thought of as the r theta plane, where x is r cosine theta and y is r sine theta. I'm sure you recall that. And z is just z. So it's kind of like polar coordinates with the z-axis through the pole. So if we have a solid region that we wanted to, let's say Q, defined like this, it's x set of x, y, z's such that x, y is in the region R, and z is between h1 of xy and h2 of xy, and region R is defined as a set of r theta, where theta goes from theta 1 to theta 2, and r goes from g1 of theta to g2 of theta, although often the g1 of theta will be the pole, so that would be 0, but not necessarily so. So if f is continuous over the solid region Q, then the triple integral of f over Q can be written like this. Of course, you knew that already, where the dA is our area element, because see the dz is already here, so the volume element dv is split apart into dz and then the dA, the area element. And then what we can do is change the area element in the way we expect by making our triple integral of f of x, y, z dv, our volume unit, as the integral where theta goes from theta 1 to theta 2, r goes from g1 of theta to g2 of theta, and z goes from h1 of xy to h2 of xy, but our function isn't a function of xy and z, it's a function of r cosine theta, or sine theta, and z. And then this is times r dz dr theta. This r would be treated as a constant when we integrate with respect to z. So to visualize our volume element, our r dz dr d theta, look at for r some number between here and here, right? Delta r is the change in r, so that will give us one of the dimensions of our polar rectangle. Delta z, of course, that one's kind of obvious, is the height of that rectangle. And the one that's less obvious is that r delta theta, but remember, if this is r from here to here somewhere, and this is delta theta, then r times delta theta is this dimension, which would be the, if we call this length and this width and this height, there's the length, width, and height, and r d theta dr dz, whatever order you want to put those in. So that's where the r dz dr d theta comes from. Just so you recall, the volume element in rectangular, delta x, delta y, delta z. But as you would expect, we're going to let the size of these rectangular parallelepipeds approach 0.